All right, so the question is, would you rather be hit by a weapon that is going double the mass or double the velocity? So if you were given a choice and somebody's going to throw something at you or hit you with some kind of weapon, you get a choice. You have an original weapon. You're not going to get hit by the original weapon, but you could get hit by a weapon that the velocity is twice as fast as the original or has double the mass of the thing that is thrown at you. Okay, so which would be the wiser choice is the question. Okay, so first make your prediction right here. Boom. And then what we're going to do down here is you can see each time I doubled the mass. Boom. So in this page, we're doubling the mass, but we're going to keep the velocity the same. If you turn the handout over to the back side, you'll see that you are keeping the mass the same, but each time you are doubling the velocity. And then we're going to graph the outcome of that and answer a couple questions and do a quick claim evidence reason about what would happen. Okay. So let's start on this side over here. So what I'm going to do is I'm going to, first of all, make your prediction if you haven't already done so. And then I'm going to do the first one and the last one and just give you some tips to set up the graph. And then I'm going to do the same thing on the other side. So here we go. So we're going to use the kinetic energy formula, which you can use this version, or the version I like to do in class is just the m times v divided in half. So the mass is 1, that's m, times v, which is 5, times 5, divided in half. That's how you'd set that up, okay? And then you can either put it in your calculator, or you can just think through it. 1 times 5 is 25, divided in half is going to be 12.5 joules. Okay, so that's the lowest amount of energy. You're going to go through and do these, just like I did here using my example, and then I'm going to do the last one with you real quick, and that will help me show you how to set up the graph. So pause the video if you need to, do these, and then check your answer with the last one and make sure it's right. Okay, so in this case, we're going to do a mass of 16 multiplied by 5 multiplied by 5 divided in half. I'm not smart enough to do that one without a calculator, people. 16 times 5 divided by 2 is 200 joules. Okay, so I'm not going to go through these. You're going to do that, but you need to set up your graph. So let's think about what would make sense in terms of counting. Now, if you don't need my help with this, you can fast forward the video or pause it, or maybe not even use the video, okay? So I already put the mass down here because we're going to increase the mass and we're going to see what happens to kinetic energy. So you guys all know we start at 0, and then let's find the highest mass we have to graph. Looks like it is 16. So I need a scale of numbers that gets my 16 over the halfway point. If you'd like to, you can pause the video and think about it yourself, which I would appreciate. Or it looks to me like probably counting by ones. So 1, 2, 3, 4, 5, all the way across, okay? What about our y-axis? Really, the only number you need to look at is the biggest number, 200. You need a scale that's going to get you up to 200 over the halfway point, which to me, it looks like, again, you can pause the video if you don't want me to just give you the answer. And it looks to me like you would count by tens, okay? So then you're just going to plot. You're going to have 5 data points. You're going to plot the mass versus the energy, okay? So you go over to 1 and up to 12.5, and you put your data point. Okay, and then you're going to do a summary of that, okay? And so you might want to look specifically what happens if you double the mass. So if you double, what happens to this? Does it increase? Does it stay? If you double this, does that double? Does it quadruple? Do you have to multiply by 8? What is true here? Okay, all right, on to the back. Similar scenario, except now we're doubling velocity. So I'm going to go mass of 5 times 1 divided in half, and that's going to give me 10 joules. Oh, maybe 2.5. Let me try that again, 2.5 joules. And I'll do the last one with you also, okay? So we're gonna have 5 times 16 times 16 divided in half. And if you plug that into your calculator, you should get 640. Okay. So now, yes, you're gonna plot all of these, but I just did the first and the last. So let me show you how to set up the graph. So zeros again. Velocity, you gotta get to 16. So probably gonna be counting by ones again. Okay, so 1, 2, etc. 1, 2, 3, all the way across. And then the harder axis is this one. So you gotta get up to 640, all right? And I'm gonna guess counting by 50s, or every other line 100. Let's see how I do. 100, 200, 300, 400, 500, 600, 700. Yeah, that looks pretty good. So then I'll put the first data point. I got to go up to 1. So now this is my X and this is my Y. Okay, so I'm going to go over to 1 and up to 2.5. Over to 1 and up to 2.5. And 2.5 is really close to the 0, so it's going to be right down there. Okay, then you should put 1, 2, 3, 4 more data points on there. Do your best fit line, answer the questions, and do the claim evidence reasoning.